In this video, we're going to be talking about transformations. And transformation is a movement or a change of a geometric figure, and we're going to be changing these figures on the coordinate plane. The two types of transformations we're going to talk about are translations and reflections. So whenever you take a figure and change it on the coordinate plane, the new figure is called the image. That's the new figure after any transformation. And of course, we've always got that word congruent. That's a reminder that anything that is congruent is having the same size or the same measure. So the types of transformations we're going to be talking about are translations and reflections. And a translation is a slide. It's sliding a figure from one place to another without turning it or changing its size at all. So all you're doing is just sliding a shape around on the coordinate grid, up and down, left and right, or diagonally. We're also going to talk about something called a reflection, and that's a flip. So a nice way to remember that is a flip. You're going to be flipping it over a line, so kind of like a mirror image. We're going to create a mirror image of something, and we're going to be reflecting it across a line, and that line is called the line of reflection. That's the line over which a figure is flipped. So this video is focused on those two types of transformations: sliding a figure and reflecting a figure. So the first one we're going to talk about is a translation. So here's an example of what a translation would look like. So here we have this letter B on the coordinate grid, and the green one is our original figure. And then if we just take that figure and slide it, here we was slid down and to the left, and we get the new figure, the new letter B in blue, and that's called the image. So we have the original figure in green, and we have the image in blue. So how do you perform a translation on the coordinate plane with figures? So here are three ways we can perform a translation. We can perform translations left and right, up and down, or a combination of left and right and up and down. So really we can move a shape anywhere we want on the grid. So in all three of these diagrams, the blue figure is the original and the green is the image. So the first one, we're going to be translating 5 units right. And if you will kind of try to visualize taking this shape and sliding it 5 units to the right, just like this, we're going to get that green image. Okay, so notice that when we slide something left or right, we're not moving it up and down. So what do you think is going to happen to the coordinates of these points if you move something left or right? Well, the x values are going to change, but the y values are not. So whenever we're sliding a figure, only the x values are going to change. So when we slide something 5 units to the right, we might abbreviate it, or the notation we use is this, like an ordered pair. So this is not the location 50. It sometimes can get confusing. That is not the location 50. What we're saying is we're going to perform this translation. We're going to move it 5 units to the right, which means the x values are going to increase 5 and the y values aren't going to change at all. So the x values change 5, the y values don't change at all. So that's what that notation is. It's how we abbreviate a translation of 5 units right. So if we were to add 5 to all of these x values, we would get the new x values in the green figure. So this point right here, after you add 5, 1, 2, 3, 4, 5, after you add 5 units to the x value, you would get the new a value, and we call that a prime. There's that little apostrophe there. That means a prime. That means the new a point. And then likewise, if we add 5 units to the b value, we get b prime. And if we add 5 units to the d value, that's actually an error here. That should be d prime. And then this, add 5 values here, that should be c prime there. They screwed that up. So in conclusion, if we were writing or translating a figure left or right, if we want to move it to the right, we're going to add to the x values. If we want to move it to the left, we're going to subtract from the x values. So only the x values change when we're sliding or translating left and right. So the same goes for up and down. So here, if we want to make this transformation, we want to slide this blue figure up 4 units. So again, we would abbreviate that or write that as a kind of like an ordered pair, 0, 4. That means the x values aren't going to change. So if you watch this slide up 4 units, it's not moving to the left or right at all. So the x values aren't going to change. It's the y values that are going to change. And if we're sliding it up, we are increasing the y values. So a slide up is going to add 4 to the y values. And if we want to slide something down, we're going to subtract from the y values. So moving something up and down only changes the y values. So again, we started with our original k. And if you add 4 to the y values, you're going to get k prime, and j to j prime, m to m prime, and l to L prime. So we can move a shape and create a new image that is congruent or identical to the original one. It's now just in a new location. And then what if we want to move something diagonally? Well, we're going to use combinations of left, right, up, down. So this translation is a diagonal translation, but it's a move 3 to the left and 5 units down. So again, we're going 3 to the left, 5 units down. So how would we perform that on our ordered pairs? We would be subtracting 3 from the x values, and we would be subtracting 5 from the y values. So take away 3 from the x values, take away 5 from the y values. So we'll move 3 to the left and 5 down. And then r goes to r prime, t goes to t prime, s goes to s prime, and u goes to u prime. So let's take a look at an example here and try to perform a translation. It says triangle ABC is translated or slid so that B prime is a vertex of the image. So B was moved from where it started to this new location over here. So B went to B prime. So what kind of a translation was that? How far did it slide? Well, this was a diagonal move. So it's a combination of moving left and moving down. So how far left did B move? It moved 4 units to the left. So we're taking 4 away from the x value, and it moved 3 units down. So that's taking away 3 from the y value. So we would describe that as a translation of 4 to the left, 3 down. So what are the coordinates of A prime and C prime? Where are the new A and C points going to end up if B was moved to its current location? So again, if I take 4 away from the x value on A prime is going to be at -3. And the y value is going to be -2. So A prime is going to be at -3, -2, 1, 2, 3, 1, 2, right here. So A prime is going to slide there. And then C, if I take 4 away from the x value, I get 0. And if I take 3 away from the y value, I get 3. So C prime is going to be at 0, 3, which is right here. And then again, if I connect those points, I get an identical triangle that was slid or translated 4 units to the left and 3 units down. Suppose triangle ABC, this original one in black, is translated 8 units right and 6 units down. So that would be a +8, -6. Find the coordinates of the vertices of its image. So we're going to perform this translation on each point to find out where their new points would be. So 8 units to the right would be adding 8 to the x value. So A prime is going to end up at 9. And we're going to take 6 away from the y value because we're translating it 6 units down. So that's going to put me at -5. So the new A prime would be at 9, -5. Now that won't fit on my grid, but I know where it's at. And B prime, again, if I add 8 to the x values, I get 8. And if I take 6 away from the y values, I'm at -2. So B prime would be at 8, -2. And C prime, if I add 8 to the x values, I get 12. And if I take 6 away from the y value, I get 0. So C prime would be at 12, 0. So that's performing translations or slides on the coordinate grid. Again, just changing the x values if you want to move it left and right. Just change the y values if you want to move it up and down, and then change a combination if you want to move it diagonally. So reflections, here's what a reflection would look like on the coordinate grid. And again, the blue is our original figure and the green is the image. So notice now it didn't slide, it was a flip. It's like we took it and flipped it over the y-axis. In this example, the y-axis is our line of reflection. So pretend like the y-axis is your mirror. If the y-axis was the mirror, this is what the reflection would look like, okay? Or pretend that y is the hinge of a door and you're taking the door and swinging it open or closed to the other side of the coordinate grid. So it's a mirror image using the line of reflection. So how do we reflect points? There's two ways that we're going to reflect points. We're either going to reflect it over the x-axis or we're going to reflect it over the y-axis. So looking at this, again, we have the blue original figure and then green is the image. So we went from this point and reflected it to this point. So look at the ordered pairs. Notice when we reflected it over the x-axis, the x value did not change. It did not move left or right. Again, it only got flipped down across the x-axis. So the x coordinates are going to stay the same and the y coordinates are going to become opposite. So notice now when we flip this point 2, 1, the x value stayed 2, but the y value became opposite, -1. And then likewise, if we were to reflect this point, 3, 4, it reflected down here, 3, -4. So only the y value became opposite. This point, 4, 4, becomes 4, -4. X value stayed the same, y value became opposite. And this point reflected across the x-axis, x value stayed the same, y value became opposite, 5, -1. So if you're reflecting across the x-axis, the x values stay the same. The y values become opposite. And then when we want to reflect something across the y-axis, it's the reverse. Now the x values are going to change. The y values are going to stay the same. So when you reflect across the y-axis, the y values stay the same. So this point became -2, 1. This point became -5, 1. This point became -3, 4. And this point became -4, 4. So reflecting either across the x-axis, x values stay the same, y values come opposite, or reflecting across the y-axis, x values stay the same, y values stay the same, the x coordinates become opposite. That can get a little confusing. So let's try it. We're going to reflect this parallelogram, and we're going to reflect it across the x-axis, and then we're going to reflect it across the y-axis. So first, we're going to get our coordinates. So I would recommend getting all the coordinates first and then plotting them so that you know you did everything right. So if we're reflecting across the x-axis, this is our line of reflection. So it's going to get reflected down or flipped downward. So my x values are going to stay the same. My y values are going to become opposite. So this is going to stay 2, but the y value is going to become opposite, -3. 2, -3. So that is right here. That's where D prime is going to be. E prime, x value stays the same. Y value becomes opposite, 5, -4. 1, 2, 3, 4, 5. 1, 2, 3, 4. There is E prime. F prime, x value is going to stay the same. Y value is going to become opposite, 6, -7. So that is here, 1, 2, 3, 4, 5, 6, 7. There is F prime, and then G prime. X value stays the same. Y value becomes opposite. That is 3, -1, 2, 3, 4, 5, 6. That is where my G prime is going to be. And again, if I connect these, you would probably use a ruler. You can see that this is reflected across the x-axis. The shape is still the same. It's just a mirror image of what it was. So now let's take the same original shape and flip it across the y-axis. That's going to be our line of reflection. So here, the x values are going to become opposite. The y values are going to stay the same. So this is -2, 3. Not sure why it made that weird mark there. And that would be -2, 1, 2, 3. There's my D prime. E prime, -5, +4. 1, 2, 3, 4, 5. 1, 2, 3, 4. E prime. F prime is going to be -6, +7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. And G prime, -3, +6. 1, 2, 3, 2, 3, 4, 5, 6. And again, you would use a ruler to do this. And there is my image reflected across the y-axis. So the two types of transformations we just talked about: translation is a slide, left, right, up, down, and reflection. We're going to reflect either across the x-axis or across the y-axis.